When you want to get off the darkest ground, but gravity pulls you straight down. Earth from a bird's eye view. You should grow feathers and see this too. When you want to get off the darkest ground, but gravity pulls you straight down. When you want to get off the darkest ground, but gravity pulls you straight down. Clear sky. When you want to get off the darkest ground, but gravity pulls you straight down. Earth from a bird's eye view. You should grow feathers and see this too. When you want to get off the darkest ground, but gravity pulls you straight down. When you want to get off the darkest ground, but gravity pulls you straight down. Clear sky.
Yeah, you better listen. I'm bringing heat. You'll be a fan when I start rapping. Way I'll have your fucking head spinning. I'm known as spit vicious. Release bombs and go tick tick. Boom, you blow me that head missing. I'm a phenomenon. Stacking cheese like it's Parmesan. 8 different flows, call me Octomom. I'm moving fast like the Autobahn. And I'm independent, so I'm not your fucking starving like it's Ramadan. Sick, twisted, gifted. Can't copy, printed. Can't hold me down. I shape shift, I'm liquid. I killed this beat, I might get convicted. They know how I move, it was predicted. Persistent, spoke it into existence. So consistent, no assistance. Hear me once, become addicted. If I rap it, then I live it. There's no cap when I be speaking this. This ain't what you want, bitch, I'm a fucking phenomenon. you want, bitch, I'm a fucking phenomenon.
Good afternoon, everybody. We seen. So I've seen some real torrential downpours today earlier. Does anybody have a good copy of 2020 paper 1 to send to me? I'm looking for a good copy of 2020. Let me see. Kinematic common paper 1. Nah. You didn't get kinematic on paper 1. Yes, the live will be posted afterwards. It has functions on paper 1, yes it does. But we go run through all that, don't worry. It has functions on it, don't worry. We go look up all that. And like I say, if anybody has a copy of 2020 paper 1, let me know now. I need a copy. Is all the audio and thing coming through fine, everybody? Just making sure everything is okay before we start the stream. Me, yeah, the video will be posted just now. Once the audio good, we got to go. Oh, the copy. Yeah, my copy real mad. But that's small thing. We go look at what we have. We should load up here. Now I'll have to let me know if I'll seeing this properly. If I'll seeing it properly, I will put it on my drive and I will send a link to the drive in the chat for them to download it and follow with me. And we're gonna start at 2021. Well, 2020. The last thing we're gonna do before exams could be we will go over 2021 specimen paper 1. Okay, scene is fine, good. Alright. Pause this. Come back here. Wood. Alright. Let me start something. Now, paper 1, easy marks. Real repeats, real lookup questions. We're doing all the papers from when AdMath was introduced till now. If we have time, we could go through some more paper 1 questions that I have. This is 2020. Alright, so let me start. The expression so by so is equal to the little factorization by grouping. Good lord. I'm just use this here. Nice. AB plus 3C minus 3B minus AC. It's just a little matter of rearranging here. AB minus 3B. Now you see how I have the AB and then I have the 3 next. Try and organize the next pair just like this, because you're supposed to realize this is factorization by grouping. So I'll put the minus AC first, and then I'll put the plus 3C next. Factorize the first pair, B into A minus 3. Keep the sign in the middle. C and the first bracket must be the same as the second bracket, A minus 3. So I get A minus 3 into B minus C. And if I'm not mistaken, this is a repeated question. A minus 3 to B minus C, D. This expressed as a single fraction is, remember I showed you the shortcut way to do these things. So we have 1 over x plus 3 plus 3 over x squared minus 9. I'm not going to dive into proper ways to factorize and an LCM and thing. We could just work with how we do the shortcut things of essence. We're going to let me go into so we have 1 multiplied by x squared minus 9 plus 3 multiplied by x plus 3 all over x plus 3 into x squared minus 9. This is equal to, if we decide to expand this here, we are looking at the answers to see what kind of denominators we're looking at. Alright, let me expand it out and then we will do the shortcut to it, right? This will be x squared minus 9 plus 3x plus 9 all over, I'll leave this as is, x plus 3 into x squared minus 9. The 9 and the 9 cancels out, and here I get x into x plus 3 over x plus 3 into x squared minus 9. The x plus 3 cancels with the x plus 3. I get x over x squared minus 9. B. Easy pickings. Zoom in a little bit. The best I could get it. If you don't have the paper, you could always let me know. I will put the link for the paper in the description, and not in the description, sorry, in the chat, so I could follow along with all the work. F of x is equal to so by so, then f of x can be expressed in the form. Alright, now let me make life a little easy for myself here now. Look at f of x, 1 minus 4x minus 2x squared. 1 minus 4x minus 2x squared. There are plenty of ways to do these things. How I will do it, I will look to see which one of the expansions below will give me the function on top. So I'm not going to factorize it. In this case, we completed a square. I'm not going to complete the square. I'm going to look to expand one of these in the answers A, B, C, or D, and see which one gives me back my question itself. So I know the first one, when I expand that bracket, I'll get a positive 2x squared. So A is not an answer. B, C, and D all give me negative 2x squared. I'll look in to see which one going and give me 1 as the positive 1 as my constant. So when I expand the first one, and I'll write it out because I know it's a little blurry here, 3 minus 2 into x minus 1 squared. I'm going to expand this out, and I know this one here will remain as 1, because x minus 1 squared is 3 minus 2 into x squared minus 2x plus 1 squared. Minus 2 multiplied by 1, that is minus 2, and 3 minus 2 will give me 1. So I'm good to go on that one so far, right? Now I'll look in to see which one gives me minus 4x. So I've seen minus 2 by minus 2x gives me a positive 4x. So I know that out this minus sign here looking like it gave me some trouble. And it could be this minus sign here as well. So what I'm going to do, I'm going to check the next one. I'm going to check 3 minus 2 into x plus 1 squared. I get 3 minus 2 into x squared plus 2x plus 1 all squared. Right, I get my minus 2x squared. I get my minus 4x. I get minus 2. Sorry. I get minus 2. I get 3 minus 2, which is 1. So now B is my answer. C is my answer, sorry. Alright, Pratish. Alright, no scene. Let me organize and get the paper here. Just give me 1 second, right? I'll put a link for it in the chat. Now remember, all the questions will come in a little after I do the solutions. So when I see the question, I go address it, right? Yeah, I know seen Pratish. Right, nice. Right, so put it in chat. Tell me if I'll again it on that link there. Should be able to get it to download there. That goes for everybody, right? Make sure you have it, so you could follow along now. I know this copy I have Railberry. If anybody have a better copy, send it to me now, please. So in the meantime, you could continue here, right? Number 4. If so by so, then A is 1, H is 3, and K is 4. So this one, again, it's asking for our next completion of the square. So I'll put this one on a color. Now, these formulas, you can use it primarily in paper 1 because it already show no working. If you're not comfortable, then you could complete the square like what we do in the videos before when we was doing completion of the square for paper 2. So A is equal to A, H is equal to B over 2A, and K is equal to C minus AH squared. So when I have the quadratic x squared minus 6x plus 13, A is 1, B is minus 6, and C is 13. So A is A, which is 1. H is B over 2A, which is minus 6 over 2 into 1, which is 3, minus 3. So I see the only thing that given me that so far is B. No other answer giving me H as minus 3. So I don't have to work out what K is. But if you want to double check your work, you could say K is equal to C minus A H squared. 13 take away 9, we get 4. K is 4. If you want to double check your work. Right? Yeah. Let me just double check it, right? I don't want to leave no stone unturned. That is solutions, that is specimen paper. Where did I do? This is transformation. Somebody asked me to do completion of the square one of these days. I just scroll into to see which part completion of the square is. Right, not there, be there, be here. Gotta be real work this day. I'm checking it over. I know one of these days I did completing the square, you know. Alright, we could just prove it for yourself, right? So I'm gonna prove it on this side here. You will take the time and prove it. Ax squared plus bx plus c is equal to a into x plus h squared plus k. Expand out. Ax squared plus bx plus c. And this is how we actually get these three formulas, is equal to a into x squared plus 2xh plus h squared plus k, ax squared plus bx plus c is ax squared plus 2ahx plus ah squared plus k. So when you compare coefficients, I get a is equal to a. I get b is equal to 2ah. So therefore, b over 2a is equal to h. And I get c is equal to ah squared plus k. So k will be c minus ah squared. So yeah, these three formulas are correct. You learned it as minus b over 2a and 4ac minus b squared all over 2a. That's not for completion of the square. Minus b over 2a is your line of symmetry for a quadratic, and 4ac minus b squared on 2a, I don't know, is that right? Use these formulas. Formulas are, we not prove it, so they are correct. Quadratic equation is such that the sum of the roots is so by so and the product of the roots is so by so. The quadratic equation is, so I'll do this a little orange here so we can distinguish the working. So we know that how for alpha beta roots the golden equation is x squared minus the sum of the roots x plus the product of the roots is equal to 0. So we have the roots, x squared take away the sum of the roots will be minus 2/3 plus 3/4. That's the sum of the roots. The product of the roots will be minus 2/3 multiplied by 3/4 is equal to 0. So yeah, x squared take away this here again we go in so. So we have 4 by minus 2, that is minus 8 plus 9 over 12 x. This becomes a minus 3 2, this you get 2, we get minus a half. Minus 8 plus 9 is 1, so we get x squared minus 1 over 12x minus 1 over 2 is equal to 0. We want integer coefficients, and the integer coefficients we need to just multiply by 12 throughout. If I multiply by 12 throughout, I get 12x squared minus x minus a half of 12 is 6 is equal to 0. So 12x squared minus x minus 6 minus 8x products to 3/4. Oh shucks. Okay, so I overshoot the question. My bad. Alright, I now see it there. I overshoot. Had luck say earlier. So you see, even I just make my little mistakes too. So and that happened because I didn't read my question properly. So just read out the question properly, please. X squared minus the sum of the roots is minus 2/3. The product of the roots is 3/4. X squared plus 2/3 x plus 3/4 is equal to 0. Multiply by 12 throughout. 12x squared plus 3 into 12 is 4, 4 2s are 8, plus 4 into 12 is 3, you get 9, is equal to 0. All positives, so it's A. Alright, sorry about that. It does happen. The set of values of x for which that is, right? Solve it here one time. We have 3x plus 2 is greater than x minus 2. 3x minus x is greater than minus 2 minus 2 x. 2x is greater than minus 4 and x is greater than minus 2. D. No, it's not minus 8. And by this minus here, go multiply by this minus here. The values of x for which this is less than or equal to 0 are, well, we do questions like this before. If it is you're comfortable doing it like how I showed you all to do it, by all means go ahead and do it. So let me just bring this around here a little bit. Nice. Yeah. If you're comfortable doing it like that, go ahead and do it like that. When you get the experience, you can notice things in inequalities and you can determine what will be the range of solutions. I know A and B, them is not solutions in my question. I know C cannot be a solution in my question because look at the inequality sign in my question. My inequality sign in the question has less than or equal to in it, which means my solution needs to have that equal to sign everywhere I see an inequality. Part C, I have a strictly less than sign in part of my inequality, so that I go work there. Part D, I have less than or equal to, and I have a greater than or equal to. Most importantly, I have the equal to sign attached to it, so I can safely say that D is my solution. Now, if I was CXC, right, I would put that D to make students check. But because they don't put that D, you gotta check. So you don't have to do no working for this one. Right? I mean, some of them might be a little scared to actually do the question, so we will still do the solution stage, right? So this question literally takes less than 10 seconds to do. But if we do the working for it, we will get 3x minus 2 over that is less than or equal to 0. When you multiply by the square of the numerator, we will end up with this. We let it equal to 0. I get 3x minus 2 is equal to 0, and I get x is equal to 2/3. Then I have 2x plus 1 is equal to 0, and I get x is minus a half. Set my number line. Set my number line. I have minus a half, then I have 2/3. I just test in x is equal to 0. If I test x is equal to 0 in my original inequality in the question, I will get a negative on top and a positive below. So I know that how this is satisfied. Section 2 is satisfied. If section 2 is satisfied, so CXC make a mistake here. This is supposed to be here. If section 2 is satisfied, then C is my answer. Minus a half. Tra-la-la-la. Oh yes, that's right. X cannot be a half. Right? If x is a half, we have this quadratic being divided by this inequality have a division of 0. So x cannot be a half. Right? Good. So number 8. So this is the solution that is satisfied. F of x is so by so, minus 3 for the domain, then, okay, so the one, the range of f of x here. Now, for the range of f of x, I could draw this down here and show it, right? The domain of a function is wherever the function exists on the x-axis. The range of a function determines where the function exists on the y-axis. If I put it a little easier for you, the range of a function is the lowest point of the function to the highest point of the function. That will be the range. And the domain will be the leftmost to the rightmost. Right? That will be the domain. So if I draw in this quadratic here. If I have y is equal to minus 2 over 9, that is x cubed. I don't know if that is x cubed, you know. It's looking like x cubed. I'll draw it as x cubed and I'll see. 2 over 9 is minus 2 over 9. X cubed. Right. So this could help me determine if it's x cubed or x squared. The domain of this function, tell me, I only concerned with this graph between negative 3 and 3. So from negative 3, which is here, to 3, which is here, that's the only piece of the graph I'm concerned with. I'm not concerned with anything else. So I will just, we go mark off what we're not concerned with. From negative 3, I'm not concerned anything beyond negative 3. Positive 3, I'm not concerned with anything beyond positive 3. So this is the only piece of the graph I'm concerned with. This is my domain. My range reflects my domain. If my domain is between negative 3 and 3, my range now will be the highest point of the graph to the lowest point of the graph between this domain. So from the graph, we can see that the highest point is 6 and the lowest point is minus 6. So if we go back in the solutions, from 6 to minus 6, that will be my domain of my graph. Obviously, the smaller one have to come first. Now, it was x cubed, right? So I will put this here as x cubed. I think I'll type over this here. Now, if the range had changed, if the domain had changed, the range will also change. So if I come back here, and I say, well, here what is the same? If instead of between minus 3 and 3, I wanted to define this function, let's say between minus 2 and 4. Now, let me say I want to define it between, let's put minus 4 and 4 now, just to have nice numbers to work with. People want to input the given values, not necessarily a Exodus, I'll show you why. Alright, so if between minus 4 and 4, I'm not concerned beyond here, and I'm not concerned beyond here. So my range, if the domain was between minus 4 is less than or equal to x, which is less than or equal to 4, then the domain will be 14 is less than or equal to f of x is less than or equal to negative 14. Alright? Ooh, that makes things a little interesting for the solution here. My solution wouldn't be this. The leftmost range will be positive 6 to negative 6. Alright? Now, that's a good question to ask. Is the fastest way to do that in paper 1 to input the values given? It can work in some cases. To me, CXE always brings straightforward questions like this. But in the event that we don't get a straightforward question, let me just pretend. Let me pretend. Let me sidetrack a little bit here, right? And I'll go come back to this afterwards. If I have a function defined as y is equal to 3x squared minus 8x plus 9. Let me draw this graph and see what happens. So let me delete all this here. I can just hide it. Y is equal to 3x squared minus 8x plus 9. Good. And I have a range, a domain attached to this. Let me say the domain of this graph is from minus 1 to 3. I'll cascade them. The domain of this graph is from -1 is less than or equal to x is less than or equal to 3. Now, stressing on what Exodus asked, is the easiest way is just plugging in the smallest and plugging in the biggest. Let me check and see. If I plug in the smallest value here, when x is equal to -1, y is equal to 3 into -1 squared minus 8 into -1 plus 9. We get 3 plus 8 plus 9. I get, what is that? 3 plus 8 plus 9. I don't know. I like my calculator. 3 plus 8 plus 9. I get 20. Yeah? I get 20. Come back here in the graph. When x is, I drew it correct, right? 3x squared minus 8x plus 9, right? When x is, oh, -1. Oh no, I want x to be 1. Sorry. 1, 1. My bad. So I will get 3 minus 8 plus 9. 3 minus 8 is -5. -5 and 9 is 4. Reflecting in the graph so far. 1 to 3. When x is equal to 3, y is equal to 3 into 3 squared minus 8 into 3 plus 9. There's 27. Take away 24 plus 9. 27 minus 24 is 3. 9 and 3 is 12. So again, it reflects the graph. When x is 1, y is 4. When x is 3, y is 12. So if I do it like this, and I conclude that the range of my function for this given domain is 4 will be less than or equal to y will be less than or equal to 12. If I come back in my graph, the range of my function is between, I'm not concerned with that fella, and I'm not concerned with this fella. The only piece of the graph I'm concerned with is this little tick sign here. That's the only piece of the graph I'm concerned with. But if you look at that piece of the graph I'm concerned with, the lowest point is not 4. The lowest point is the minimum point. Always. Do you see that, Exodus? So there will be cases where it's not just a straightforward substitution of values. The easiest way to do questions like this for paper 1 is to check my minimum or check my maximum point. We can do that using calculus. Just differentiate, put it equal to 0, check. If a minimum point occurs between the domain, then I cannot just substitute values inside of there. I have to check. If a maximum point exists in between the domain, again, I cannot just substitute values inside of there. So if I do the solution for this one here, and I want the proper range, we can say this is not true, since a minimum point exists in the domain. So the easiest way to do it will be calculate the value of the minimum point. Remember, we need the y coordinate as the minimum point. So we just differentiate. dy dx is equal to 6x minus 8. Set it equal to 0 to get the stationary point. dy dx is 0. 6x minus 8 is 0. 6x is 8. And x is equal to 8 over 6, which is 4 over 3. When x is equal to 4 over 3, y is equal to 3 into 4 over 3 squared minus 8 into 4 over 3 plus 9. Jump on your calculator. You have calculators in an exam. 3 into 4 over 3 squared minus 8 into 4 over 3 plus 9. But it is an improper fraction, 11 over 3. So the lowest point on my graph is 11 over 3, and the highest point on the graph by the substitution we did before is 12. So my range for this function will be 11 over 3 is less than or equal to y is less than or equal to 12. That will be my real range for this given domain. So it's always good to check if a minimum point exists inside or a maximum point exists inside of the domain. And it takes the practice. For this one here, an inflection point exists in between the domain. But inflection points don't really play up too much in maximum values and minimum values. Right? There can be an inflection that exists in between a domain where it doesn't affect the range of the function at all. Tell me if that's okay. Right, good, good. Once it good so far. Right, again, it's a little blurry, so can't fight up with that. A function is defined by f as such that x is mapped onto 1 over x plus 1. X is not equal to minus 1. The value of f inverse of 1 is... Alright. I don't like to beat around the bush. Let y equal 1 over x plus 1. Interchange x and y. I get x is equal to 1 over y plus 1. Solve for y. X into y plus 1 is equal to 1. Y plus 1 is 1 on x. Y is equal to 1 over x minus 1. So this could be f inverse of x. Could be 1 over x minus 1. What is the value of f inverse of 1? F inverse of 1 is 1 over 1 minus 1, which is 0. The functions f and g are defined by so by so and so by so. The composite function gf is defined by, right? So f of x is 2x minus 5. And g of x is 4 plus 3 over x. The composite function f g of x, so, g f of x. G f of x will be g f of x is 2x minus 5. So wherever I see x, I put in 2x minus 5. 4 plus 3 over 2x minus 5. And they did simplify it. So let's go ahead and simplify this here. We have two fractions. So, and so. So I have 4 into 2x minus 5 plus this over 1. 3 into 1. All over 2x minus 5. That is 8x minus 20 plus 3 over 2x minus 5, which is 8x minus 17 over 2x minus 5. C. Which of the following graph depicts a function? We just jam with vertical line test. If it cuts once, it's a function. A. If all you want to go over vertical and horizontal line test, let me know. The expression that, when simplified, is equal to, this is a repeat question again, root 5 minus 1 over 1 plus root 5. It looks like the denominator was rationalized, so we multiply by 1 minus root 5 over 1 minus root 5. This is root 5 into 1 minus root 5. Take away 1 into 1 minus root 5. And the denominator becomes a difference of 2 squares. So we will get 1 squared minus root 5 squared. We get root 5 take away 5, take away 1 plus root 5 all over 1 minus 5. Root 5 plus root 5 is 2 root 5. Minus 5 minus 1 is minus 6 over minus 4. We can factorize it up. 2 into root 5 take away 3 over minus 4. You could cancel with you, we get 2 on the bottom. So minus a half into root 5 take away 3. Alright, so they just distributed the minus inside. So this could be 1 half into 3 minus root 5. D. Good so far? The value of 2 to the power x, where, alright, 2 to the power z. There's a next repeat question again. 2 to the power of z, where z is equal to 5 plus log of 3 to base 2. So we get 2 to the power 5 plus log of 3 to base 2. Let me show you how to cheat a little bit here, right? If pressure take you in questions like this, say a prayers, take a deep breath, and remember your change of base formula. Change of base formula from logs. If I have log of a to base b and I want to change this to base c, this could be log of a to base c over log of b to base c. So what we can do, I can change this log here to a base that we have on the calculator, base 10 or base e. Let me change it to base 10. So log of 3 to base 2 is actually log of 3 to base 10 over log of 2 to base 10. We can find this on the calculator. So now this entire expression, I can input it on my calculator. So my calculator, 2 to the power, open bracket, 5 plus log of 3 to base 2 is log of 3 to base 10, which is log of 3, divided by log of 2. Close bracket equals 96. Let's see. Alright, so that's just a little trick. To work it out long ways, 2 to the 5 multiplied by 2 to the log of 3 to base 2. This is 2 to the 5 multiplied by, if I have, the law says, if I have a base raised to log of a number to the same base, this is equal to the number 8. So this is multiplied by 2 cubed. So 2 to the 5 multiplied by 2 cubed, 2 to the power 5 multiplied by 2 cubed. Oh good lord. Multiplied. Where's multiplied? Log 2 to base 3, tra-la-la-la, is 5, right? 5 plus, oh, yeah, 3 to base 2. Right, so if I have log, if I have 10 to the power, I'm just checking something here. 10 to the power log of 6, I suppose I get 6 as my answer. Yeah. So 2 to the power 5 multiplied by 8. Why am I getting 256 for? It's 2 to the power that. Right, plus. I want to sort this out. Oh, this is 3. Sorry. My bad. It's not 2 to the power 3. So 2 to the power 5 multiplied by 3, 96. My bad. I lock it. Alright, so we're cooking with gas. Given that log of, I'm going to assume that is x cubed, log of x cubed to base 2 is equal to 6. We can use the law that says we can change a log to an index and an index back to a log. So this becomes 2 to the power 6 is equal to x cubed. 2 to the power 6, 64. Cube root of 64 is 4. Good. Good to go. Alright, so give me 3 minutes. I'll be right back. Anything you all want to discuss it in the chat. If I see anything that I have to jump in and say, I'll jump in and say it. Any questions, ask. I'll be back in a couple minutes, okay? Alright, sorry about that. Back. Cool. I see nobody discussing anything, so I guess everybody good so far. Which of the following mathematical statements are true? Alright, so if I have log of p q to base a, that's log of p multiplied by, no, that is not true. So 1 definitely is not part of the answers. So one time I can see C is the solution. If 1 is not an answer, 1 exists in each one of these things here. Given that so by so is so by so, the value of x is, right? Bring this across here. We have 3 multiplied by 27. I don't know if that is 3x or that is 2x. We go try 3x first and then see what is the scene, right? Is equal to 9 to the x. Bring all the bases to be the same thing. 3 by 3 cubed to the 3x is 3 squared to the x. 3 by 3 to the 9x is 3 to the 2x. 3, 1 plus 9x is 3 to the 2x. The bases are the same. 1 plus 9x is equal to 2x. Move the 9 across. 1 is equal to 2x. So I thinking that will be a 2x. Here carry the 2020. So I most believe this fella here is a 2x. Right? So we could do it over with him being 2x. So 3 multiplied by 3 cubed to the 2x is 3 squared to the x. 3 multiplied by 3 to the 6x is 3 to the 2x. 3 to the 1 plus 6x is 3 to the 2x. Equate them. 1 plus 6x is equal to 2x. Move the 2, move the 1. 6x minus 2x is minus 1. 4x is minus 1. And x is minus a quarter. B. So this is 2x as the power here, right? The sum of the first n terms of a GP is S sub n is 4 to the power n take away 1. The common ratio is minus. For the series, alright, so let me really tell me to say whether things is true or not. You can make the assumption, you could put one on one together, I mean, let good sense prevail. Yes, Carrie, it is 2020. If you scroll back up in the chat, you'll see the link to get a copy of the paper. Right. So let me just check and see if the sum of the first n terms of a GP is S sub n is equal to 4 to the power n minus 1. The common ratio is minus 1. We will check and see if we can figure out what that is just now. The first three terms are 3, 12, and 48. Now, if 1 is true, 2 is not true. S sub 20, we can't see it too clearly, man. I don't want to make no assumptions because you had to pick things for your answer. That looking like 2 to the power 4n. Okay, I'll say. Alright? So, I'll put in a highlight here. I'll see if I can get a better copy of this paper. I will see if I can get a better copy and I'll come back to this question, right? This is k is equal to 1 to 3 of 1 over k is, alright, so the summation from k is equal to 1 to 3 of 1 over k. K is 1. When k is 1, we get 1 over 1, which is 1. When k is 2, we get 1 over 2, which is a half. And finally, when k is 3, we get 1 over 3, which is a third. The summation says to add them up. 1 plus a half plus a third is 1 and 5, 6. Change it. 11 over 6, D. The common ratio of the geometric progression is, it will just be Tn over Tn minus 1. So our further down term divided by the term right before it. 12 divided by 8. 4 into 12 is 3. 3 over 2. The sum of the odd integers between 10 and 50 is, this is the next repeat question. The odd integers are, from 10 to 50, we have 11, 13, 15, 17, 19, and so on. And this in itself forms a AP. First term is A, which is 11. Last term is L, which will be 49. And the common difference, D, will be 2. So the sum of we had to figure out how much integers we have, how much odd integers we have between 10 and 50. So if you check them, from 10 to 19, I have 5. 1, 2, 3, 4, 5. So I have one set of 5 there. From 20 to 30, and next set of 5. 30 to 40, and next set of 5. And 40 to 50, and next set of 5. So I have 4 sets of 5s, which is 20 terms between 10 and 50. 20 odd integers between 10 and 50. So the sum of the first 20 integers is n over 2 into a plus l, which is 10 into 11 plus 49. 10 into 60, which is 600. If you wanted to take the long way around and physically add them up on the calculator, go ahead and do so. Nothing wrong with that. The coordinates of the center of a circle with equation so by so is, so they're just for the center. If I have x minus a squared plus y minus b squared is equal to r squared, the center is AB. So if I can make an equation look like this, then I can determine what the center of the circle is. So the equation is x minus 1 squared, so that piece good to go, plus, but the next piece is y plus 3. I want a minus there. Minus, to maintain the plus 3, I have to put a minus 3 here. So the center of the circle is 1, comma, minus 3. Let's see. The points of intersection of the line and the circle are, so you can solve it simultaneously if you want, or we can just substitute values inside of the two equations and see which one maintains equality. So let me check and see. I'm writing over the equations because it's kind of difficult to see. Y minus x minus 2 is equal to 0, and x squared plus y squared is equal to 10. Alright, I'm checking the first set here. I'm checking it for x squared plus y squared equal to 10. It's a little easier to check. For the first one, x is 3, y is 1. So I get 3 squared, which is 9, plus 1 squared, I get 10. The second one, I also get 10 for the second one. Actually, for all of these coordinates, my second equation will always be satisfied. And you can check it and see. For every single one of these points, my x squared plus y squared will always be satisfied. So take that as an exercise, figure out why. So we're checking it in y minus x minus 2 is equal to 0. So in the first equation, I will have 3, 1. So I'll have 1 minus 3 minus 2. That is minus 2 minus 2. No. Second one, I have minus 1 minus 3 minus 2. No. The third one, I'll have minus 1 minus 3 minus 2 minus 1 plus 3 is 2. 2 minus 2 is 0, right? So that working there so far. And let's check minus 1 and minus 3 now. Minus 3 minus minus 1 minus 3 plus 1 is minus 2. No. So the answer is D. If you wanted, you could have solved them simultaneously. Again, it is taking a little practice. It will be a little confusing for number 22 if you don't take your time. If you want to solve them simultaneously, 1, 2, you come across, you say, here is the scene. From 1, you can see that how y is equal to x plus 2. Jam that in equation 2. X squared plus x plus 2 squared is equal to 10. X squared plus x squared plus 4x plus 4, bringing the 10 across, is equal to 0. 2x squared plus 4x, 4 minus 10 minus 6 is equal to 0. Jump on your calculator and solve it. Mode 2, 2, you get your quadratic calculator. A is 2, B is 4, and C is minus 6. So x is 1 and minus 3. So x is 1 and x is minus 3. So I check and see which one of the equations, which one of the solutions here give him a x coordinate of 1 and a x coordinate of minus 3. So for my x coordinate is minus 3 and my x coordinate is 1. The first one, my x coordinate is 3, nope. My x coordinate is 3, nope. My x coordinate is minus 3, but my next x coordinate is minus 1. So it wouldn't work there. So it will only work for D. No, it's not B, Gerald. We can draw it and see. Right, I'll draw it for you as well. Y is equal to, sorry, y minus x minus 2 is 0. That will be a straight line. Our circle is x squared plus y squared is equal to 10. Points of intersection, going across here. Points of intersection are 1 and 3, right? 1 and 3, and minus 3, minus 3, minus 1. So D is the answer. Number 23. The line y is equal to 2x minus 7 intersect at the point. Again, just check and see which one satisfies both equations. So for part A, when x is 4, y is supposed to be 1. So I plug in 4 here. I get 4 2s are 6, 6 minus 7, air working. Part 2, when x is 8, y is 6. 8 2s are 16, 16 minus 7 is not 8. When x is minus 5, y is 4. Minus 5, we get minus 10 minus 7, negative. Last one, when x is 0, y is minus 7, so we get D. The vectors I and j represent 1 kilometer per hour east and north respectively. A man sails a boat on a lake such that the velocity is minus I plus 2g when there's no current. If there's a current of 3I, then the resultant velocity v is given by, ooh, this is a nice question. Let me read it over again, right? The vectors I and j represent 1 kilometer per hour east and north respectively. Cool. So I means east. I means east, so negative I will mean west. J means north, so negative J will mean south. So a man gone on a boat and he traveled minus I plus 2J. So he traveled minus I plus 2J. So he up here when there's no current. If there is a current of 3I, then the resultant velocity v is given by, if it have a current of 3I, he would have go back 3I in this direction because it has no G current. So if here is minus I, so this is minus I plus 2G. If I add 3I to this here, I'll get 2I plus 2G. A. For 23, I got A. I get A for 23. A can work there. No, A cannot work there. And I'll show you. Y is equal to 2x minus 7. Intersecting x plus 3y is equal to 7. Points of intersection is 4, 4, 1. When x is 4, oh shucks, I put 4 2 is 6. Sorry. My bad. Sorry. My bad. I multiply 4 by 2 and get 6. Hard luck. Sorry about that. My bad. Let's move on. Number 25. Two vectors are equal if they have the same magnitude and in different directions, have the same magnitude in the same direction, are parallel and in different directions, have different magnitudes, so they have to be the same magnitude and the same direction. 25. 26. The position vector of 2 points A and B relative to an origin O are given by so by so and so by so. The modulus of AB and the angle AB and the angle AB makes with the x-axis respectively are not a bad question. So OA is equal to 30. OB is 85. AB is AO plus OB, which is negative OA plus OB, negative 30 plus 85 minus 3 plus 8 and 0 plus 5. Right. 5 is AB. The modulus of AB is the square root of 5 squared plus 5 squared, that is square root of 50. So it's either C or D. Now it's time to figure out the angle. So, and the angle AB makes with the x-axis. So AB is 5. So if AB is 5, then AB is somewhere up here. 5, we make a right angle triangle. U is 5, U is 5. We need to figure out this angle theta. So we can use trigs. That could be tan theta is equal to 5 over 5, and theta could be 45 degrees. So C. The trigonometrical expression so by so is identical to, now I know a lot of you all go see this one time and decide to leave it out. I showed you all two ways to do this. One is by doing the proof, one is taking an angle and plugging it in there. So to me the easier thing to do is the proof. The longer method will be the substitution of an angle. So I get sin x over 1 minus cos x plus sin x over 1 plus cos x. Again, two fractions, so. Sin x into 1 plus cos x, and this is also a repeater, plus sin x into 1 minus cos x all over 1 minus cos x into 1 plus cosine x. The top we get sin x plus sin x cos x plus sin x minus sin x cos x. So the top will be 2 sin x. The denominator works out to be 1 minus cos squared x. You can do the expansion on your own and see. And I sin squared x. So 2 sin x over sin squared x, you cancel it, one of you on the below, and I get 2 over sin x as my answer. If you all want to know the other way, how to substitute values inside of there, just let me know and we could do it. The figure MON below shows a quarter circle with radius 4. The perimeter of the figure in centimeters is, right, more than one way to do this. We can do 2 pi r multiplied by theta over 360, or we can do arc length is r theta, a half r theta, no, r theta. So the arc length S is equal to r theta, the radius is 4, and theta is pi on 2. So we get bam bam, we get 2 pi plus 4, 8 plus 2 pi. factor it 2 into pi plus 4 d. The graph of y is equal to sine 2x is, and I explained what this 2x does. The 2x, it plays with the period of the graph. Now by stating that, well, the regular period of a sine curve is 360 degrees or 2 pi. When the period, the number is increased, common sense will dictate that how the period also increases, but the period decreases when the number increases. So for sine 2x, instead of one revolution being made in 2 pi, one revolution will be made in half the amount. So one revolution will be made in pi radians. So C is the answer. Because you see one revolution here, it making pi revolutions, in pi radians, sorry. If this was sine of a half x, then one revolution will be made in 4 pi. It's not there. The smallest positive angle in radians with the range so by so that satisfies the equation so by so is, okay, so we have 2 cosine theta minus 1 is equal to 0. One time, if I have I'll put cosine theta minus 2 is equal to 0. This will have no solutions. And you can check it and see for yourself. So here I have cosine theta is equal to a half. Theta will be cosine inverse of a half. Let me check and see what this is in degrees first. Cosine inverse of a half is 60 degrees. Converted to radian, 60 degrees will be pi on 3. The exact value of cosine of 5 pi on 12 is now I'll show you how to break this up. We're going to do that for multiple choice because to make sense showing you working. What I going to do, I change my calculator to radians. Cosine 5 pi on 12. (0.258819045). But I'm storing the whole thing in A. And I just want to check each one. A quarter into root 6 plus root 2. A quarter into root, a quarter into root 6 plus root 2 equals a quarter into root 6 minus root 2 into root 6 minus root 2. If I take away a from this, I should get 0 if that is the answer. I get 0. Yeah, I get 0, so that's the answer. B. If you want to take a check the next one as well, a half into root 6 plus root 2 and a half into root 6 minus root 2. Root 6 minus root 2. So B is the answer. Correct that off. Number 32. The size of the angle x measured in radians is, so that is 60. That is 68. Let me check and see. If that is 160, I'm pretending it's 100 is 60 degrees first, right? 100 plus 60 is 160. So the next angle is 20 degrees. So 20 degrees multiplied by pi over 180, this will give me pi on 9. So if that really is 60 degrees, it's pi on 9 radians. If it is 68 degrees, 100 plus 68 degrees is 168 degrees. So the next angle will be 12 degrees. So 12 degrees multiplied by pi over 180. 12 over 180 is pi on 15. So we don't have pi on 15 there. So it really is 60 degrees. Right, so easy stuff. If sine x equals something, then cos 2x equals, I don't know what sine x is, so I'll leave this one out again. I'll go see if I get a better copy again to do those two questions we leave out. Sine of alpha minus 45 is equal to alpha minus 45 degrees double compound angle sine alpha cos 45 minus cos alpha sine 45. This could be sine alpha by 1 on root 2 minus cosine alpha by 1 on root 2. So we have 1 on root 2 into sine alpha minus cosine alpha. C. F of x is that f, that looking like f double dash x. So f of x is sine 3x minus cosine 4x. When I differentiate sine, I get cosine, so it's 3 cosine 3x. When I differentiate cosine, I get negative sine minus 4 sine 4x. So this combines to give me a plus. F double dash x. When I differentiate cosine, I get negative sine. So this could be minus 9 sine 3x. When I differentiate sine, I get cosine. 16 cosine 4x. D. The curve has the equation y is equal to f of x. The curve C has the equation y is equal to f of x. C is a stationary point at negative 2, 5. If f double dash x is x to the power 4 minus 15, then, so we can just check it and see. F double dash x is x to the power 4 take away 15. At x is equal to minus 2, f double dash x is minus 2 to the power 4 minus 15. That will be 16 minus 15, which is positive, which means it's a minimum point. C. The differential of this fella here, there's quotient rule. Don't bother to write your statements if you're comfortable with it. If you're not comfortable with it, please write your statements. Statements just help you get a little guidance going along the way. So u is 2x minus 1, du dx is 2, v is 5 minus x, and the v dx is equal to minus 1. So dy dx, I substitute in it one time, is v du dx, take away u, the v dx, all over v squared. We get 10 minus 2x. This minus and this minus here combines to give me a plus. So I get plus 2x minus 1. So you cancel with you. 10 minus 1 is 9. So I get 9 on top. Positive 9 on top over 5 minus x squared. A is the answer. The point P11 lies on a curve. the value of the gradient of the curve at P is, so we had to differentiate it. Jesus Christ. Again, another quotient rule. U is 3x minus 2. du dx is 3. V, 2x minus 1. dv dx is equal to 2. dy dx is v du dx minus u dv dx all over v squared, which is 2x minus 1 squared. At the point x is equal to 1, you could substitute one time. At x is 1, you don't have to go and bother to simplify all this here. If you're comfortable substituting something exactly inside of here, go ahead and do it. At x is equal to 1, I will have 2 minus 1 multiplied by 3. Take away 3 minus 2 multiplied by 2 all over 2 minus 1 squared. So 2 minus 1 is 1, 1 by 3 is 3. Take away 3 minus 2 is 1, 1 by 2 is 2. Over 2 minus 1 is 1, 1 squared is 1. So 3 minus 2 is 1, at x is equal to 1, dy dx is 1. Given that y is equal to that, then dy dx is equal to, so that will be like 2x squared. So again 4x plus 3 cos x d. If the integral of that is equal to 6, then that is between 1 and 4, right? Nice. Alright, so we have the integral between 1 and 4 of f of x is equal to 6. And we want to determine the integral of 1 and 4 of 4 f of x dx plus 5. We can pull out the 4 on the outside for the integral 1 and 4 f of x dx plus 5. This whole thing here is 6. 6 was 24 and 5 is 29. The region R is enclosed by the x-axis. The curve y is equal to minus x squared plus 2 and the lines x is equal to 0 and x is equal to 1. So it's enclosed by the x-axis, the curve, and the lines x is 0 and x is 1. Okay, cool. So that will be a straightforward integration between 0 and 1 of minus, I've taken that to be x squared. Let me try it and see. Is either x squared or x cubed. So that will be minus x cubed over 3 plus 2x evaluated at 1 and 0. So minus 1 over 3 plus 2 minus a third plus 2. I like to double check on my calculator regardless of what. Minus a third plus 2. 1 and 2 thirds, which is 5 on 3. So I'm going to leave that there as x squared, right? We will leave it as x squared. If it's x cubed, it will be the exact same procedure. The integral of that dx, I showed you all how to do the shortcut to the chain rule for integration as well. The integral of 2x minus 4 cubed dx will be 2x minus 4. We add 1 to the power, divide by the power, the new power, and multiply the denominator by the differential of the bracket, plus k. So it will be over 8. So it's 2x minus 4 all to the power 4 over 8 plus k. Alright, and finally, no, not finally, 43. The region bounded by the curve, the x-axis, and the lines x is equal to 0 and x is equal to pi is revolved about the x-axis. Alright, so revolution about the x-axis is pi y squared dx. So it will be the integral x is equal to pi. Okay, so 0 to pi. Y is equal to 2 sine x. So y squared is 2 sine x all squared. So you pull out the 2 pi into 4 sine squared x, 0 and pi. So luckily they didn't actually ask us for the value, they just want how the integral will look. So I could pull out the 4 pi on the outside, 0 and pi of sine squared x dx. 4 pi, 0 and pi. Alright, so they just pull out a 2 pi on the outside then. So it have plenty ways you could do it. So if I leave a 2 pi on the outside, 0 and pi, I can leave a 2 attached to the sine squared x. So 2 pi, actually none of these here will, y is equal to 2 sine x. Oh, they just pull out the 4 and leave the pi inside. They just pull out the pi and leave the 4 inside. So A is the answer. Right? It is the same thing as saying pi, the integral 0 and pi of 4 sine squared x. Why the whole paper can be looking like this? Integral of y. So like I say, if y is equal to sine x, dy dx is cos x. So if I integrate cosine, I get positive sine. So if y is equal to that, then the integral of that, I will get 3x cubed over 3 plus sine x. So we get x cubed plus sine x, well, obviously plus a constancy. And the integral of this, so again, if y is equal to cosine x, then dy dx will be negative sine x. So when I integrate sine, I get negative cosine. So when I integrate cosine against sine, so this could be sine x minus, when I integrate sine, I get negative cosine. So this combines to be a positive plus c. Sine x plus 2 cos x plus c and d. Alright, that's it for one of the papers. Now given that we started pretty early, Admaths is quite next week Wednesday. We had time. So if all you want me to do any whole topics, I need to know. Leave a comment when the video goes public on YouTube. Just leave a comment stating you want whatever topic covered. I don't want to wait until last minute to have a 6-hour stream to do everything on paper 1. If we can look up things little by little, we will be good to go. I don't want to leave the videos too long for people to watch it out. So like an hour, 40 minutes, hour 45 minutes is fine. And yeah. So if anybody have any questions, feel free to ask it. I'll wait around. You can ask it now. Tomorrow, same time, same place, we will be doing another paper 1. Sunday another paper 1. Monday another paper 1. And if we have to do any additional work, we will do it. So I'm waiting around. If anybody have any questions, feel free to ask. Alright, so I see nobody have any questions, so I guess I'll see everybody tomorrow, same time, same place. Laters.